By the mid-1970s, the US government had a very big issue when it came to programming languages and how they were used in the military. There wasn't really any single standard programming language for military applications at the time. And Fortran and COBOL could only get you so far since they lacked the features that you really needed for these like embedded real-time projects, right, in the military. When it came to weapon systems or aviation equipment or radars or whatever. And by the mid-1970s, there were over 450 programming languages that were in use for every project by the US government. And of course, this incurred a huge training cost, and there was a serious lack of organization among government software projects, which is when the US government started funding the development of the Ada programming language. Ada is a strongly typed programming language that is still in use today throughout the aerospace, defense, and medical industries around the world. I only started learning Ada this week, and my interest in programming in general has definitely waned in the past couple months ever since the Osaka OS release because, it's just gotten stale after a while. I've been mostly studying math in my free time, and it's gotten pretty hard to encourage myself to get back into writing software. And I think it's mainly because I just wanted to do something new with regards to computers. Because, with regards to software, I've basically just been chipping away at like the same two things for like the past 2 years or so, right? But Ada has been a big part in reinvigorating my interest in computer nonsense again, because it's just a very cool language from a design standpoint. And the main centerpiece of that design when it comes to Ada is its strong type system. Types in Ada are very interesting because you don't just define them using like keywords for integer or float or boolean, and then just define other stuff on top of that if you want to make them more complex. You usually describe types and how they behave in some certain way, and then the compiler allocates, whatever memory it thinks that type should have, and that's just what the type is, right? I'm sure the compiler is building it from more primitive, like integers and operations on integers, but from the user's perspective, you're just describing the behavior of a type and getting it, right? If you want to make a type that's indexing some known array, an array of a known size, and that like wraps back around to the beginning, right? In C, you might just define an unsigned 8-bit integer and just manually modulo it from the array size and wrap around like that. So basically the behavior of the type is done by the programmer. And you can get fancy with type stuff in C, but you'd have to like do that yourself. That's not like something built into the language or the compiler. But in Ada, you just write type index is mod n, right? Whatever the size of whatever you're indexing over is. And it just behaves exactly like that. You can also define types with custom ranges, or you can define types of floating point values, where you're able to specify how many decimals of precision there are. There are also natively built-in task types for concurrency, and then there are access types, which are Ada's equivalent to pointers, and they can be used to give specific permissions to, with regards to like reading or writing a given object in memory. Since Ada has a static and strong type system, there is no implicit conversion between types, so every conversion has to be explicit, and operations are not defined between two different types, right? So there are these things called subtypes, which, from what I gather, are compatible with their parent types in a certain regard. I don't know how much of this is really accurate because I just started learning the language this week, so I'm still trying to wrap my head around like all the different concepts and stuff. But the type system for any programming language to me is the most, typically the most interesting part of it, right? That and how it handles functions and procedures. In Ada, functions are known as subprograms, and first of all, they have to always return a value, and you can't call them just as normal statements, right? So usually in like a programming language, you'll just call any function, like a void function or whatever in C, and it doesn't have to return a value. And it could just be dropped in main as like an extra block of logic. But in Ada, it has to be only called when it's being returned to when it's being assigned to a variable or in some sort of expression. There are procedures that are where you don't have to return a return value, and the parameters for procedures can be defined as in or out. So it's basically just like you can read or write to any given variable that's passed to a procedure. And you could explicitly say that we're only going to read from this variable, or you can explicitly say that we're going to read and write to this variable. And it also supports nested procedures, which is, I think that's something I barely got working in IUniScript, if at all. But it's cool to see it, that's like a thing in Ada. That's something that's actually used in Ada as well, from what I've seen online. There's also a subset of ADA called Spark, which is this way for formally verifying ADA programs. Essentially, you can define certain conditions, I think that are called contracts, where upon the entering or exiting of subprograms, the prover, right, which is like this automatic theorem prover that shows that the software has like no runtime errors using like static analysis or whatever the fuck, is able to verify that without running the code, is able to verify that yes, this function when entered will hold this condition to be true, or this loop will hold this condition to be true over every single iteration. I can also formally verify that there aren't any memory leaks or use after free errors, which I don't think the ADA compiler does by default. And you know, obviously I'm not writing software for like jet engines or some shit, but the whole process of like formal software verification is very interesting to me. You know, ironically enough, ADA was the programming language that was used for some software that was running on like some spacecraft that was being tested by the European Space Agency in the 90s. And it was like one of the, I think it was called the most expensive software bug in history, but some integer overflow caused like a fucking cascade of like horrible fucking consequences to happen, where the ship started like going on its side and just fucking exploded. I don't think any people died, thankfully, but I wonder if that single incident was responsible for like, if a bunch of ADA people came together and be like, okay, this is a fucking bad look, maybe we should like make a way to fucking formally verify our programs or some shit. I mean, it's not like it was ADA's fault that happened, but my only knowledge of the language came from that one incident that costed the fucking European Space Agency $370 million. I don't really have any plans for making stuff in ADA yet. I'm sort of just playing around with it at the moment. But I don't plan on completely fucking replacing like all my C++ stuff with it. I mean, I don't like C++. I do like C++. I don't know, it's kind of like a weird fucking thing. I mean, you know, if I start a new project anytime soon in software, it would probably be with ADA. But it might not be the correct tool for a given application, so I just might use C++ there instead. But, you know, it's very refreshing to use a language that is new and exciting in a certain way, as opposed to C++. I mean, new to me at least, right? Also, it's just like way fucking prettier than fucking C++ or Rust or anything that touches embedded stuff. ADA is by far the most beautiful. I mean, it was made specifically so that non-programmers can read it and understand it, so it's, you know... And it's not like it has tough fucking competition with C++, bro, that shit's ugly as hell.